Good afternoon. Oh, I didn't speak yet. Good afternoon, everyone.
Good afternoon.
We don't have another lab today. You're asking me. We don't have we have a lab session, yes, but
Okay.
we don't have another lab.
Wait, by the way, did you get the thing from my email? Like, I didn't know where to submit it, but I submitted it through the email. But then they also submitted it as well to the Blackboard as well later. Like, is it going to be counted as late, even though I finished it even though I sent it to you through email before?
It's okay. Yeah, you mean your lab report last time from last time?
Yeah, I gave it to you in your email before the deadline. So like,
Okay, I don't deduct the point, but you just make sure every time you submit the full report. I didn't see your fourth part in your lab report, like the one in Blackboard.
You didn't?
I received your lab report, but your lab report does not include the fourth part.
Huh? Wait, but I thought the lab report is the first part where you put in all the results and all like the data and stuff.
Yeah, but you didn't calculate the footstep. What's your work?
I did calculate the footsteps on all that. It's all in the lab report. You're not supposed to combine them?
I didn't see okay, we can discuss this later.
Okay.
Yeah. Okay, so we got 24.
Okay, I had a question. Do we need to turn in the labs on both physics sections on Blackboard, or just the one for CD4?
Only for CD4. So your lab report will be me for me to grade them. So I just take care of all your lab reports, the lab session, and the presentation part. Yeah.
Like the original one was saying that I was late, so I didn't know if I had to put it there too.
Yeah, Blackboard is like a platform for all the TAs to communicate. Sometimes you get the email from other TA, or sometimes you submit to their. I don't think you can submit your lab report to other TAs session because your name was not in their system. I'm not sure how you could submit.
No, yeah,
You mean you can submit?
Yeah, because there's a section for CD4 and then one that just says CD, and the same assignments from CD4 pop up on CD. So I didn't know if I had to turn it in on both for it to count or just the one.
Oh, just this one, CD4. I think the one for CD, who wrote CD is the TA. I think the TA didn't specify which section he was in.
Okay, thank you.
Report, but do I have to send it to the man? Oh, you just asked? Was Gujar? Was you?
Josh, yeah.
Okay. Did I answer your question?
No, yeah, you did.
Okay. Okay, I think we can get started. Let me share my screen. So today, so first, like a lot of students, they're confused about the lab report template. I don't have I don't have like a strict rules for the lab report template. I just like the only requirement for you is to like write clearly what you do, like you write for the introduction, why you're doing this experiment. And second, you have to write the procedures, which is like the steps, like what you do. Like let's say if sorry. Let's say if someone else was reading your lab report, then they will know, oh, they can follow your steps to like really copy, they can repeat your experiment. This is the core, this is the key. And third, I would like to hear more feedbacks from you in the conclusion, either what you learned from this lab or like what you don't like. You can just tell me, then I could maybe could try to adjust the lab content within try my best to adjust the lab content. So this is basically, and the most important is the lab results. So basically you follow the lab menu, you list your table, your graph, and maybe sometimes they ask you a question, you just answer like how many, how long it takes you to work for 10 steps. So you just give me the question, list the question, and fill out your answer. That's pretty much all for the lab report. But also, I did select a few lab report for your reference. Uh, so everybody had their different style, but I just want to show few of them to make you have a better understanding about lab report. Before I do that, I would like to ask Michael. Is Michael here? Oh, Michael.
Yeah, I'm here.
Can I use your lab report?
Sure.
Do you mind if I share your lab report?
No, so it's all good. You can use it.
Thank you. Okay, I'm share here. So I think Michael did a good job in writing a lab report. So the introduction is, you don't have to be read so long. So measurement is a key part of physics, like basically blah, 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 and lab procedures. So what he did, for step 1, step 2, step 5. So step. So yeah, sometimes maybe you want to make sure people didn't didn't follow you, maybe provide 1 or 2 pictures, but it's not required, but it looks nice. And part 3, the steps, 1, 2, 3. And basically you write down what you do. Okay. So also he provides a picture. We can see, oh, this is really a bonus because I can see the ruler. So when later when we try to calculate the error, so I can really tell if he give me the right error, because some people give me 1/32 or 1/16. I really don't know what your ruler look like, because it's really weird for me. So yeah, it's very good. So we can see here. This is centimeter, right? It's 0.1 centimeter. So the error would be 0.05 centimeter. So we can really easily tell. So the part 4, step 1 to 10, and lab report. So you see here's introduction, lab procedures, and results. So part 1, part 2. So it's very clear and easy. It makes people it makes it very easy for people to follow. So oh my god. Yeah. So the lab results and part 3. So it's very clear, and really, this is the kind of a lab report I want you like write about, like make it very clear, and you don't have to spend a lot of time to like talk about the background, the procedures. You just list like 1, 2, 3. It's very clear. And you see here, so the question is listed and the answer also answered here. So this is very good. And conclusion, what he thought. And yeah, I know the first lab is it's pretty easy. It's just like a lot of tedious work. But yeah, understand which unit need to be used. Okay, so this is very, I think that's a very good example. I have another one. Maybe I should put here. Let's, Mark, do you mind I share your lab report? Mark is here. Let me see who else. Yasin is here.
Yes.
But you're Mark or Yasin?
I'm Yasin.
Yasin.
Yeah.
Okay.
You could use it. I don't mind.
Okay. So so his Yasin's lab report also like so his name, the time, lab 1 introduction, and the procedures like 1, 2, 3, 4, 5. So basically, like we can see Michael, he lists all the procedures at the in the procedure session. So here Yasin did like every lab report and follow the result. You see, and this okay. Wait, let me see. Oh, you're okay. So okay. I got it. So he lists the procedures like each one like one step for one experiment. Yeah, it's also fine. Yeah. So like I just want you like know what you're doing. This is basically the point for the lab report, writing a lab report. So like Mark is here. Is Mark here?
Yes, I'm here.
Do you mind I share your lab report?
Yeah, you can share mine, no problem.
Okay. So this is Mark's lab report, the introduction. So he didn't list like one by one, like step 1, step 2, but it's like so it just like write a sentence to make people understand what he did. Here, I really like the graph. Okay. So basically, yeah, he didn't like list every details, but he provided like very clear because his like lab report looks very clean. I mean, like it's clean, like it's nice, like people can really like can find it like informations easily. And I really encourage everybody to submit a lab report either with Word or PDF. Because like I know other like some students, they submit their lab report by scanning their their writing lab report. It is fine, but it's just like hard for me to grade to read. I really appreciate if you can like really submit a PDF, PDF or a Word document. So yeah. So I guess you guys have a sense about what a lab report look like. So I really don't want you to spend a lot of time writing a lab report because like it doesn't make any sense. But just make sure make sure you understand what you're doing, and you can convey the idea concisely to other people. Like you know like what you did. Okay, Sabiha.
Professor, I just have a question.
Yeah.
For lab report, for the procedure part, do you prefer steps or paragraph form?
I prefer like steps, like one by one. You don't have to list very long, just like
okay.
It's very clear to me. Yeah, but everybody is doing great in the lab report writing. The first time you don't have any experience, but you figure out your way to write a lab report. That's a very good performance. Like I think you guys did great. Okay, So just a quick, any other question for the lab report? Wait, am I recording it? So the second part I want to say is like, because next week we will not have lab session, but we will have a recitation. So last week we had our first recitation, and we had like some discussions about the homework or some questions or problems you have from your class, from the lectures. I really appreciate like everybody can upload their questions before the recitation. So I make a Excel sheet for, so next time, next week is March 2nd. So you can list questions like which chapter you're learning, let's say chapter 4, and the question maybe 40. Tell me the page. Well, I should update a little bit. Question number and page. So here we assume everybody is using the latest latest textbook, which is let's see which one. This one, the Fundamental of Physics. I think 11th edition. So so we know we can say I can after you submit, I really appreciate if you guys submit before Sunday, before the recitation Tuesday, so I can go over a little bit your questions, so we can focus more on the recitation class and discuss about your concerns and what you confused about. Yeah, what you want to know. If you don't understand the concept, we can go over about a little bit, go over the concept. If you're, somebody have a question. Or you list your name, so I know if you don't feel comfortable, you can put anonymous. And the question update time, just list the time. Let's say we will have a recitation on March 2nd. Maybe today you encounter a question you want to ask next Tuesday. You can update time, update the question time by today. I mean, write the today's time, the today's date. That's basically. Yeah, I upload all our recording in YouTube because I'm not a YouTuber, so nobody else will watch my video. So I think yeah, if you have a so you don't have to be concerned your privacy was the issue. And also I try to pin myself on the screen, so even if other people are watching our lecture video, it wouldn't be it won't they won't see everybody else except me. So yeah, I think it's much convenient because last semester I keep the recording in a Zoom cloud, but they were deleted within 14 days, after 14 days. So I think the permanent way to keep all these videos is put on is upload to the YouTube. Yeah, you guys have any questions for the recitation part and the recording? Oh no, it hasn't. No, there is no requirement. So right now I'm not sure which chapter are you go over now. Which chapter are you learning? You guys are on the same class? So last time we were, so difficult. It can be anything, like later, maybe after, let's say after the midterm, maybe you go over like a chapter 10, chapter 11. You can also ask any questions. Let me see. So I think the first chapter is measurement, second motion, vectors, force, kinetic energy. So basically, you can ask anything. Let's see the question. Yeah. Just make sure you upload it before. Otherwise, I don't have time to like review your questions. Maybe it will like take some more time in the recitation class. I want to save you guys more time so you can like really be very efficient in doing your work. Also, like we can finish early if we're like make everything like goes efficient and effective. Yeah, that's my goal. Any other questions? If not, then we'll probably go to the lab session of vectors. Vectors. So how far has you guys been studied from the textbook? Like, which chapter are you in now? Did you already learn the vectors?
We're in chapter 4.
Chapter 4. Chapter 4 is what? Oh, motion. So you already learned vectors already. Okay. So can you guys open the lab menu? So if you are seeing this page, we go to lab 2, which is vector 207. Everybody's following me? Wait, I just wanna like ask question, like do you guys feel comfortable if I upload the video to YouTube? Thanks.
I think it's fine.
Okay. Because I pinned myself on the screen, so yeah. Okay, so the vectors, let's see. So today, we're gonna go over vectors. So it's pretty easy. We will practice a little bit in the class, and then you will do the homework. And what else? And you try to solve a real life problem for the last section, last part of the lab. Okay, so let's get started. So if you open this link, it will direct you to the simulation page of our lab. So today we're gonna like study vectors. So there are two quantities that normally introduced together are scalars and vectors. So the only difference between scalar and vectors is the vectors has a direction while scalar does not have a direction. So the examples for scalar are like 10 apples, 9 bananas, and the vector quantity has both magnitude and direction. So we say like someone travels 12 kilometers due north, or 3 meters due east, cycling at 5 kilometers due west. So they're always like when you say like a quantity of a vector, always comes with a magnitude and the end of the direction. So when we so figure A shows like a vector. So this is a tail, this is a head. So the length, the absolute value is the magnitude, and the head indicates the direction. So when you try to like, we know how to calculate. So here comes the questions. So how do we like describe a vector? So we have two ways to measure. One is to measure its magnitude. Another way is to measure its direction. So the way to measure its direction is by using the angles. Like here we use the geometric angles. Let's say any vectors can be divided by like a horizontal component and a vertical component. So the horizontal component of vector, let's say this ax, this is the vector called a. So the horizontal component of vector is ax. So ax equal to a times cosine theta. The theta is the angle between the horizontal line with the vector, and the value of vertical component is a y. A y equals to a times sine theta. So that's how you calculate its horizontal component and the vertical component, and you use this angle to indicate the direction. So like when we try to calculate the let's say the magnitude, and we have we use like the what's it called, the Pythagoras Theorem. So basically you say ax squared plus ay squared equal to a squared. So you can, this way you can calculate the magnitude of a. So when you do, so like in math, we have we have like the basic like functions. You add two numbers together, you subtract the two numbers. In the vectors, we do too. So the vector addition is when you want to add two vectors by the head to tail. So basically, you add two vectors, you make their one vectors, the head of one vectors connect to another one's tail. Then you draw from the beginning of the original, you draw from the beginning of the tail to the the last head. So that's the sum of the two vectors. Any questions so far? Okay, I just assume you don't have questions. We will practice more to make a better understanding. So here is calculate the magnitude, and yeah, we can start to practice. So the first one, let me see. So the first one, you click Explore 1D. Basically, it just like give you make you familiar with how to play with this simulator. You can click like the horizontal line or the vertical line, and you have sum, you have values, you have all the grade. The grade is helping you to really calculate. Let's say you say one grade represents 1 kilometer, then you know 10 grade means 10 kilometer. So you can just drag one vector. Let me see. Sorry, I didn't see the chat. Really apologize. Okay, leave it here. Then you can really you can drag it. So you see, the magnitude is 17. There's no unit because there's no unit. Sorry, just. So like you can add two more. If you click sum, there will be like a dark dark blue will show the sum of these two vectors. And they say if you drag this one longer, then the sum will be longer. And you can check the values as well. So one is 5, another is 20, the sum will be 25. If you want to erase, here's the eraser.
I have a quick question. So does it matter if the vectors are connected, like we
No,
see
it
here, or?
No, no, it doesn't matter. You see here, doesn't matter. It will automatically sum them up. So let's say we put another one here. It's also 5. So it doesn't matter. But when you do your calculations, you may want to make them together, connected together. Yes, everything will be posted online. But I do take attendance by the end of this class. So yeah, but the resources will be available. Okay, so basically that's the first part of the experiment. So I don't really want you like, I mean, for the first part of the lab, you don't have to write anything, you just practice, and we already practiced together in the class. Just make sure everybody is following me in the class so we can play around together. If you have any questions, just like ask me immediately, I can answer your questions. Like everybody like right now is kind of playing around with these vectors. Right? So you already learned vectors, right? So maybe it's not like very difficult for you. Give me some feedback. Okay, so we can like go a little bit faster, you know. So then the second part is explore 2D. So like earlier we explored 1D, so it only has one axis. So when we explore 2D, so the vectors have can have a direction. You see, you can just like move like you just use your mouse to drag into any directions, and so you can use the component. It helps you to really digest to measure the x component and y component. Let's say this way. And we click value. So the total is 11.4, and the x will be 9, the y will be 7. Let me try to make it bigger. Okay, so it will automatically, so when you click this component, it will automatically enter the value. If you don't click value, then it nothing show, you don't know, you still have to measure, maybe you count how many grade, grade you have, and which how much it represents for each grade. And this is this. If you click value, then it will automatically show the value for each vectors for each vector. And here's the angle. You click angle, so it shows it's 40.9 degrees. You can also add them up, like say this one and this one. It doesn't matter which direction. If you click a sum, then it'll be okay. It's like clear. So if you want to hide all this like x, y, then you just here there's a button with the I and the slash. That means no I can see. So you don't see all these sub components. So basically, this is add up. This is the dark blue is the sum of all these 3 vectors. And yeah, so let's see. Any questions so far?
How are we going to show part 1, 2, and 3 in the lab?
You don't need to write any report for part 1 and 2.
Explore this.
Oh?
Part 1 and 2 is just telling us to explore this. They didn't give us like particular work.
Yeah, just to like give you a feeling how it works.
So do we write that in the lab report that I don't know, we did?
Oh, you don't need to write anything for 1, 2.
Okay, thank you.
Just like like how to play with one direction and the one dimension and the two dimensions.
So part 1 and 2 is more for us to learn, and 3 and onward is for us to submit the work. This is what I'm getting,
yeah,
right?
from part 3. I think part 2 is. Hello, can you hear me?
Yeah.
Sorry, can you repeat your question?
No, I was saying, so part 1 and 2 is for us to like play around with the graphs and stuff, vectors, and 3 and onward is what we do and submit to you.
Exactly. Yeah. Yes. So, any questions for how to use the simulator here? Basically, we use a sum as to show the sum value, sum vector. And if we click value, then it shows all the values and the angles. If you don't need them, and then just don't show them. And so there are different sections. You can try to dissect to the x component, y component, or you show the directions. But I prefer this one because it really like give me a clear idea about the x-axis and y-axis, how much it goes. And if you don't want them, you just use the eraser. So here, look at this one is eraser. You can just delete them. You see it's all gone. But you cannot restore them. So yeah. Okay, so here's the lab. We go to the lab. So if you look at the lab menu, before we jump into the lab session, we have to know a few concepts about equilibrium. So when we do that, when we do like 1, 2, like we have two. Let's say we have two vectors. We have a sum, and the balancing. So the sum vector is called resultant. And the one that is opposed to resultant is equilibrium. Equilibrium is the same, has the same magnitude as resultant, but it has the opposite direction of resultant. So basically, let's say, so it has 180 degree. Let's say we can use one. We can just use one as example. Let's say this is the S. You say here's the S. This is the sum, and value. Put a value here. So we say the sum is 10, and the direction is 0 degree to the x-axis. So the equilibrium here will be 10 as well, but the head will towards this direction, to the minus x direction. You see here, the resultant is directing to the right side, and the equilibrium will be 10. The head will towards the yes, will be 10 and minus 10. So we'll direct to the left side. Let's see. Any questions for the equilibrium?
Do we provide its angle?
Yes, I mean depends if they ask you. I mean always provide the angles. Angle shows the direction because it's vector. But if you say like you already have a direction, then you don't have to say it. Let's say you have an angle but to be sure, I think every time you have to specify the angle. All right. So if you're also using the same simulator, we can do the lab one together. I mean, the lab together. So first, you click the lab. So we are in this lab web page, and you click. You will choose two vectors. One vector is v1. Okay, I don't want show sum for now. So let it be like 5 to 10 unit. Okay, this is 10, and the direction will be 10 to 70. Just move a little bit here. So I just go here. So if you want to check the angles, just click here. So this is 26. Okay, whatever. So I just like add one more. So maybe it's also 10. Okay, so this is 2. The second will be 10 to 20. Okay, and I'm reading the step 3. Click on the same color vector as in 2 above and drag another vector into grid. The second vector is V2. So basically this, for the first one we draw is V1 and the second is V2. So they have a requirement for the V2. Let magnitude of V2 be between 10 unit and 20 unit. So we have 14.9. And the direction theta will be 100 to 222. So apparently 42 is not okay. We go 100 to 220. Okay, maybe this is okay. This is like the magnitude is above 10, but smaller than 20, and the angle is 130. So it matches the requirement for V2. So the question is to determine the sum of the vector v1 plus v2. So they basically ask you to do a sum of these two vectors. And the fast way is to click sum. Oh, wow. I didn't know. Wow, that's a like coincidence. These two added together is like a very straight. It's like a vertical vector. So this one will be the resultant. So you record your data in the table, and okay. Then you determine the magnitude and the direction of equilibrium. So as we mentioned before, equilibrium is the same as is the same magnitude as resultant, but is the opposite direction, with 180 degrees difference. And record a screenshot of picture of your simulation grade for use in your lab report. So you basically, after you've done this, you take a screenshot to show me like what you get. So I can say, I can double check your result. If your result matches your like what you did on the grade. Let's take a look at the table. So it's a just go here. So the table says, so the V1, and the angle V1x, V1y. So how do you get this number? And the V2, the absolute value, and the angle. This absolute value, it means its magnitude, and V2x, V2y. So how do you get those numbers? Anybody know how to get these numbers from this graph? Okay, I'll call somebody.
You can click those little indicators on the right, the little traces. I'm pretty sure it'll just pop up. No, down right next to the eye. The one to the right.
Oh, this one.
No, up. Yep, that one.
Right. So you can get this number, and if you click the angle, so before, let's say we don't have anything. Oh, we have a sum. So we click this one. So it shows like, okay, this direction, this vector 1, vector 2, they all have like a x and y components. And if you click the value, it will show you, okay, how much it in x direction and in y direction. So basically, say here v1x, v1y. You just put the number here. This is for v1, v1x, v1y. And this is v2x, v2y. And if you click this for the angle, and you will get the angle here. So the default, the x-axis, it will be the will be 0. So it compares to, you see here, the angle from x-axis to this vector and here. So you can put all this number here and value. Okay. And also the magnitude of each vector, you can also get those values on here. So it's pretty easy to find vector 1, vector 2, and resultant. So here, this is very, very interesting. So the resultant, they ask you what you calculated and what you observed. So it's very easy to know like what we observed, because when we say we observed, we just click sum, and then we have, well, let me adjust a little bit. So this one has an angle. So if when they ask what we observed, you just put the value here for, this is the resultant. The resultant, the x component and the y component in the table, and as well as the angles. So you put those numbers in the observed column. But how do we get the numbers for calculated? Anybody have a question? Have a idea? Okay, I'll call somebody to answer if you know, volunteer. Jack, is Jack here? Okay. Yes, the observed value will be the sum. Okay, I must a little bit fast. Okay.
Well, I mean, you could calculate just by adding, right? Like you'd add the x component of each and the y component of each.
Right, that's correct. So basically, Rx is like V1x plus V2x. This equals to Rx. And Ry equal to V1y plus V2y.
I have a question.
Yes.
We should include the angles, right, when we are doing each component. So when we have a component, it should say like the length times cosine theta, whatever.
I mean, for now, like the angles, just say these numbers. Cosine theta is like when you don't know. Let's say we don't know this angle. Let's say we don't know that. Okay, for example, this one. So we don't know this angle. We cannot measure. We cannot measure this angle. But you have to specify what angle it is. So you can use but you know what the cosine is because you know the x, y, and the resultant. You know those values. You know how to calculate the sin theta, right? Sin is like 4/8. It's 1/2, right? So when you try to, this is the sin value. It's just a value, but if you want to get to the angle, you have an arc, the inverse geometric function, right? You learned that?
Yeah.
You know what I'm saying, right? You
Yeah, I know
understand?
what I'm saying. I'm just asking that we should just include the angles when we're calculating each component. That's all I'm saying.
Okay. Okay. Yeah. So if you calculate, you want to calculate the angle, you also add them together. And but this one you cannot add up together to r, right? If you calculate the r, you have to do rx squared plus ry squared equal to r absolute value squared. So that's how you calculate r magnitude. So for the angles, Vx, Vy, you do the sum to get all these numbers. But for r, our absolute value, you don't add one, you don't like sum up V1 plus V2. It's not right. It is wrong. Yeah, you guys have a question for how to calculate the R resultant?
Wait, can you go over how we calculate absolute value of R again?
Yes. So R, like earlier we mentioned how to do the calculation. We do the Pythagoras Theorem to calculate the R, the resultant. So here R squared equal to Rx squared plus Ry squared, right? So you already get Rx and Ry, so you can get R. Let me see. Does it make sense?
Sorry, can you show it on the graph thingy?
Okay. Okay, so let's say so for example, this one, this will be V1, V2. So you add, so this is X. So the total are, so the only thing you are not sure about is how to calculate the absolute value of R, right? The resultant.
Yes, yeah.
So let's say, so this is a triangle. You can see this is a resultant, this is a triangle. But if you don't know this value, oh my God, I should make it. Wow. Let me see. Okay, I just adjust a little bit. So here, if you don't know this one, you have this one. You know how to calculate the Rx, and you know how to calculate the Ry, right? You have problems in. Okay.
No, it's good.
Okay, so this is like a straight angle. So you have the equation to calculate this one by, let's say this is R. So this Rx squared plus Ry squared equal to R squared.
Oh, okay, I see. So yeah, I see it now.
Okay. R equal to the root of, wait, not Phi, Mia, your equation is not right. Your equation should be root x squared plus y squared. It's not x plus y squared. Okay? Okay. Do we have to show the calculation in the report? Yes, please show your calculations. It will be very easy. You don't have to explain, oh, why do this calculation? You just like show, like basically it's like me follow your flow. Anika. So far.
Can you tell me what's the equation for the vector, I mean R is again?
Okay, R squared equal to R x square plus ry square. So this is I don't know where to find. So here you can Google this. Oh, not root. Sorry. Wait, root. Let me see if I'm calculation. You have to manually count the magnitude of vector. No, you don't need to count. So you have the x and y. You already have this number. Let's say, let's look at the table. You have v1x, v2x. So rx, you don't have to count. You just like v1x plus v2x equal to rx. And ry equal to v1y plus v2y. I mean, I'm trying to answer the question Fadia. Okay. What is equilibrium? Equilibrium is the same. Yeah, so anybody have a question for resultant? It makes sense to everybody, right? So the observed, they just like get all this number from the graph. From the graph, you see the sum, like you calculate this is x, this is y, this is the r absolute value. And the calculated is a little bit tricky. Basically, add this two together to rx, this two together to ry, and this two together. Here, please note the angle here. If it's above, if it's like a let's see. So if the angle here is a little bit tricky. 14. The angle, like a maximum, is well, like like this is if you towards one direction. If you're towards on the right side, it's a positive. If it was like left side, it's negative, right? So here I want you like note. Let's see here, the first like vector is 14 degree, and the second vector is 122. So if you add them together, oh, it should be 136. Why the sum is 70? Right? So you cannot like directly add them together. So what you would do is how do you like? So let's say you have like this one vector, and this vector is this direction, right? And when you add these two, the total, the resultant will be from this one to this one. So this is the resultant, and you have to well, let me see how you calculate. You have to measure the direction from the tail to the. Okay. And what you can do is. What you can do here, you can just like measure another one. Okay. Well, okay, you can just, oh, let's try another color. So you can measure this one, make it together, because this orange kind of measures the yellow measures the sum of these two. No, you cannot simply do the math. So, okay, here's how you do. You use a different color. You choose a different vector, different color vector. If you choose the same color, it will add up together. It will add to this one. It will mess up your calculation. So you choose another color, and you see. So this is also you calculate because you are using a third way to calculate. So here's the resultant, and here's like the angle. Yes. So you see here the angle from x to this is 70.3. Yeah, it's the angle from the tail to head. What do you mean? The angle always from the x-axis, like horizontal. Horizontal is 0. The degree of the horizontal line is 0. If like it's a vertical, it's 90 degree. So that's by our default. So like I'm not very sure about your question, Matthew. But like what we do here is we use a different color to measure from the tail to the head. You have to make these two together, tail to the head. Tail to the head. Just connect it together. And then you can just read the value from here. Okay, 70.3. Any questions? Matthew, it's x-axis to the head. Yes, right, that's correct. X-axis to the head. Connect the vector of V2 to the head of V1. The tail of vector 2 to the head of vector 1. Okay. Okay, sounds all right. So any questions so far?
Yes, Professor. Sorry to maybe make you go back here, but just for the calculated resultant for the angle, I noticed in the formula up there, it's saying in the lab itself, it says like the tan inverse of AY over AX, and so is that the two angles that we're getting from our original vectors? I'm sorry, I'm just trying to. Yeah.
No, the angles here, what I said is when we try to calculate the angles, we use a different color to measure from the tail to the head. But the condition for this, you have to make these two connect together. If you like moving this one, like they are not connect together, you try to measure like from the tail to the head. It doesn't make any sense, right? You have to make these two connect together. Wait. And then you measure. So basically this one is exactly the same as this one, it's the sum. But this one is like how you calculate them. Understand?
Sorry, I'm just trying to follow along on the simulator itself here. So that's you moved the sum the sum vector over. I'm confused. Okay, so wait, those were your two original ones.
Two original ones. This is the blue. This blue are two original ones, right?
Okay.
So the dark blue calculates the sum of this blue because they are same color, right? Yep. Automatically it measures. But what we want to do is we want to say, okay, if we get the same answer by literally we are measuring it. So we use another color to really measure these two to make sure if these two are same. Yeah, you will get it. You can like make a hypothesis like those two, all these values are same. You say if they are same, they are supposed to be same, right?
I'm sorry, can you repeat that? Sorry.
So basically one is your observer for the resultant R. one is observed. Observed is you read from the sum. And the calculated is we use like an orange color to calculate the angle. And like Rx, Ry by using V1x plus V2x, or you can also read from the yellow, from the orange vector. Right.
Okay, I see what you're saying by using the orange now. That makes sense.
Okay. Yeah. Hassan. Okay, I call you Hassan. Hassan calculated very well. The light blue is our input. So the dark blue is the sum automatically generated. And the orange is like we manually calculate the sum. You compare this, you put the values into here. This is a dark value, this is dark blue, this is the orange, and these two are light blue. Make sense?
Yep. No. Yeah. I get it now. Using the orange one, it makes sense.
Okay. So the last part is equilibrium. Equilibrium is very easy to calculate. So anybody know how to calculate this? How to calculate equilibrium? So equilibrium is like it has same magnitude as a resultant, but the angle is opposite. Like either you add up for 180 degree or minus 180 degree, it will be the same. Let's say the resultant is here. I'll give you an example. The resultant is 70.3. So okay, I wanna get another. Okay, so here we are using the blue color as our experiment, and we are using the orange color to do the measurement, like manual measurement. So let's say I want this one. I wanted so this is a sum. The dark blue is a sum, and I want to use the orange to represent the equilibrium. So first I have to get the same magnitude, right? Yeah. So this it's not the same. Okay, 1, 2, 3, 1, 2, 3. Okay, so this is the same magnitude, and you want to say, okay, here's a 70.3. So the equilibrium has 180 degrees difference. So either we add 180 degree to 70.3. That would be 250.3, right? Oh my God, I should not point to the head. Okay, I have to point the head, otherwise. So it's 250. Well, okay, so you see, after it passes 180, it becomes negative. So you see, after if you add 180, it is above 180. So let's say 70 plus 180 is greater than 180. Then what we'll do is 70.3 minus 180 degree, because it doesn't make sense. Either you go this direction or you go the other direction. Both 180 degree doesn't make any sense. Either you plus 1 or you minus 1, right? So okay, so we minus 70.3 minus 180 degree, it will be 109.7. 109.7. Okay, it's hard. Okay. Okay, it's very close. But
can you just type the angle on the top? Can you just type it at the top and it changes at the top bar right there?
Top bar?
To the left there, at the top right here.
Where it gives all the values.
Where it gives the values. Maybe you could just type the angle there. No, the values to the left of where you're looking at right now.
Wait, what?
It's
all the values
on top of
at
the
the top.
graph.
Yeah.
Wait.
On top of the graph, over the graph.
Oh, oh, right, yes. You mean here?
Yeah. Oh, never mind. I don't think you could change it.
Work. Yeah, it doesn't change. But you're not required to draw this. You just like, I just want you to understand how we get the equilibrium. You don't have to draw an equilibrium here. You just make sure you understand. So here I want to calculate to make sure everybody know either we plus 180 degree or we minus 180 degree, because it doesn't make sense. You see here like 180 degrees here, and if we like rotate on the other direction, it's also the same position, because like the system automatically default if it exceed 180 degree, it will be minus. So like it's hard. You have to calculate. There's so much math. Just want to simplify a little bit.
Do you have a preference for the actual lab? Would you rather it be the positive or the negative value of the angle?
No, I mean here I just no, I don't have preference, because like it's very easy to, because here you can, let's say this is 10 degree, you just like maybe like this is minus 170, right? Or you just plus, because this is math, like you just plus 180 or minus 180. But here what I do, I try to like do the math to make you understand. So it is a rotation of 180 degree. So you don't have to do this. You don't have to do the orange for the equilibrium in your lab report. It just make you to understand how we get to the conclusion. But here it's very easy. It's like, let's say this is 10. You can either write minus 170 or you can write 190. So it doesn't matter to me, because it's just a 180 degrees difference, right? Okay. So the equilibrium value is, it's like it's same. They have the same magnitude. The angle will be 180 180 degrees difference, because the opposite direction, and ex, ey, and you will definitely choose one direction is opposite, right? Let's say if you ex, let's say ex is 5, then you can either choose ex equal to minus 5. $180. Yes, you can do, wait, no, that's not correct. Wait. No, that's not correct. Anika, so if we say you just use the number, original number to plus 180 or minus 180, you cannot use 180 to minus or plus, because you will get a very different number. So let's say it's 70. Yes, that's correct. 70 minus 180. Let's say if you are using 180 minus 70 is 130, right? 130 will be here. So it definitely doesn't like a 180 degrees difference. Okay. Let me see. So here, I think the angle, where are we? The angles, you just put like plus 180 or minus 180. And the EX and the EY, they are asking you the absolute value, right? Also, because you list the angle and you list the absolute value. So all these two rows are absolute value. You don't have like a, if you get a negative, that means this is, I don't think there's no negative. Just make sure that these two rows, they doesn't have a negative, because it's absolute value. They're asking you for the absolute value. So the XY, so EXEY will be the same, because this is the same as the magnitude. Any questions?
So the last two rows should have the minus or plus, whatever the direction it is, right?
No, they will be all positive because you already
All of
indicated
them?
the angle. Yeah, all positive. Because you already indicate the angle. If you don't have an angle, maybe your minus will be indicating the angle, indicate the 180 degree or whatsoever. But if you have the angle indicated, already indicate the direction, then all these two and here. Actually, this column, this row, this except the angle, all others are positive. Okay, so
Professor,
yes.
wouldn't the EX and Y component would be negative because that's not like, that's before the absolute value?
Oh, yes. Oh, wait. Let me see. No, let's say if you have a negative value, let me see. You can see this one. This is, okay. So here is a negative value, but it didn't indicate the direction. Yes, I think here, okay, we say what I said is wrong. You can have a negative value, but this negative value doesn't indicate you have a like negative, like a, that doesn't indicate the direction. So you have a like a negative, like say this one, for example, this is the X, this is Y, and the X will be -7, just indicate the number. So yeah, how to say that? So basically what you do is just like follow the instruction and record the number to your table. And the only calculation you have is here. You try to calculate the R. If you use the orange vector, you don't really need to calculate anything. So here for equilibrium, you have to calculate the angle, which is plus or minus 180 degree. So other than that, you just follow the instruction and record the value. If you click the value here. Yeah, it does have a like negative value.
So for the Vx, the x component of the vector 2 would be -7, right? On the table.
Yes.
Oh, okay, thank you.
And then you tell me what's the difference you observed between the calculated and observed. Maybe your calculation will show you a little bit of error, but it won't like, vary much because it's supposed to be the same. And okay, any questions?
There is this extra row at the bottom of the table. Are we supposed to put something there, or was it just a mistake or something?
Where? Actually, oh, this is a mistake. I mean, not a mistake. Maybe we just, I don't know, like we don't need this.
No, okay.
Okay, we try to solve the last question. Okay, I erase this one. We can do the practice here. So a pilot, okay, I need to move this one. A pilot is flying, excuse me, her aircraft at speed 10 kilometer per hour due north from here, from Long Island to Connecticut. There's a strong wind. Okay, attention here. I want you to change 65 kilometer per hour to 70. So it will simplify your calculation. So we don't use 65. We don't use 65, we use 70 kilometer. So the wind is 60 kilometer. Wind speed is 60 kilometer per hour. Okay, so because otherwise it's very difficult for you to describe what you how the pilot is doing. Blowing from west to east, the airstrip upon which she has been given clearance to land is oriented in north-south direction. Okay, so basically we have so the pilot is heading to the north. It's heading to the north. With its speed is 210. So it says like 1 grid represents 10. So we just need 21. Wait, it's 10. 1, 2, 3, 4, 5. Okay. 21. It's 21. And the other is, wow. The other, like a distribution is the wind. Let me see. It's 70. 1, 2, 3, 4, 5, 6, 7. So this is 70. So 1 grid will represent 10. So the sum will be like it's a sum. So actually, what she's doing is she's flying this direction, right? So they ask you to determine the resulting direction and speed of her aircraft. So basically, you determine. You can put the value in the angle here. Determine the resultant. You basically tell me she's heading north, like how to say that. So basically, the angle is here, and her resultant is 20.1. Give the direction theta in which she should point her aircraft nose in order to mount the course to her destination. So you don't have to, so in the real case, north will be 0, but in our case, it's like east will be 0. But you don't have to like really care about this. You just like do what you like write down what you observed here. I don't want to confuse more to like do another conversion of the direction. However, measured in counterclockwise direction. So the vectors, so this vector on your grade. Okay, so number 4 is to get direction. Record a screenshot of the picture simulation grid of your lab report. So what do you want to do in step 4? I think you just have to figure out the angle of the resultant. So the angle is resultant. And then they ask you when she tried to land her aircraft, she needs to slow down, which means the speed here will be slower. And the wind wouldn't change. So they ask you, how will this affect her ability to stay on the course for north-south aligned runway? So basically, they ask you to maintain a direction of like a north to south. So basically, you have to like let's say her speed is. Okay, wow. Thinking maybe. So So what if she wants to do? She has to remain on the course to make sure her flight can land it in the right direction, right? So you have to make sure the resultant will be on the north to south direction. And this is her speed, and this is the wind. So they ask you what direction she has to, like what she will do to adjust that. So you have to tell me, like, okay, she has to operate in a 109 degree to make sure she landed in this direction, right? And they ask you, what if when she landed, she has decreased her speed? So you see she decreased her speed. So then there will be the resultant will have like a slightly direction change. So to compensate that, you have to make the angle even larger. Let's say, like let's say if the resultant, if her speed decreased to 16, then her angles will be larger, even larger. If she had a smaller speed, she really has to have a like a very big angle. To compensate those the direction change, right? So this is what we'll do. What she will do. What corrective action can she take to compensate and ensure she remains on course as she slows down to land? So this is what I said. When she decreases her speed, she has to really enlarge the angles to make sure she has overall like a resultant degree will be north to the east. North to east. A nose, point her aircraft nose under to. A north-south aligned. Yeah, the north-south aligned like a course. North-south aligned course that she has to make sure the resultant will be like a straight line. Any questions? Any questions for the real practice? Yes, there will be a recitation. If you don't have any questions, then we don't have to meet. But if anybody, wait, we have to meet. I think we have to meet. We have to meet next week. You update your questions in a spread Excel sheet. Yes, we meet every week. Oh wait, we're not done yet. We have to take attendance.
Real quick, Professor, for this part 4 for number 5, you're not expecting an exact value of how much she needs to keep changing as she decrease her speed, just a general idea that she'll need to take a wider angle.
Yeah, what she will react.
Okay.
For my nose, I'm very allergic. Yes, you just give me like what she would do, adjust to make her direction like upper towards north.
Got it.
Any other questions? Okay, then we take attendance. We will be done. So far, how do you feel like the class? Is that difficult?
It's a lot of information for like one day to all learn, kind of.
But you have 3 times a week, right? Or two times a week? 2 times a week. Do you feel like
it's 3, I guess, because like I mean Monday and Wednesday, and there's also Tuesday, so it's 3 times per week, I guess. But Tuesday, Tuesday is like kind of a separate class, kind of, but not really, because it's still lab and stuff. So I guess it's 3, but like it's technically 2. But
okay, so what about third one? Like the third one is separate?
Well, this is the third one. This is lab.
This lab, okay. Let me get my yeah, the lab report will be due March 2nd. And like if you have any question, first watch this recording, and then you can also like write me email, because last week, so like on Tuesday there was the email bomb. Yeah, it's like a lot of work to do. So I really recommend you can watch the video first if you get some confused part. If you really don't understand, just write me email. Okay. You think, okay, Arthur, you think like you have too much information for this class?
Yeah, never mind. Yeah, it was just a lot of information for today, to like vectors and all and that kind of stuff. It's quite a bit.
Vectors you already learned like in the class. This is not the first time you know vector, right? You learn vector?
Sort of, I guess.
Vector is what's this? So let me see any questions. Lepson was very helpful. Oh, thank you. Recording from, I'll update, I'll upload I'll like update the link in Blackboard, but you can watch later. You know the link to her YouTube. Yes, I will like upload in the YouTube. I also want to, okay, so I also want to keep a track of my teachings. I think it's also experience for me. So I don't really want to like keep my recording on Zoom after 14 days it's disappeared. Like, yeah, so I would, oh my God. No, I don't want to become a YouTuber though. I just want to kind of record, like keep track my like teaching life. So okay, let me find the grade CD4. Okay, take attendance. So we from bottom to top. How to say UI? I really don't know. Like, how to pronounce you?
Hello?
Huh?
Oi.
Wait. Yeah, if you don't have, sorry, wait. Okay, thank you. Trung.
Yeah. Yep, I'm here.
Okay, talker. Sorry, the pronunciation is very bad. Talker, like a header. Header, sorry, apologize. Header. Emmer.
I'm here.
Windsor.
Here.
Bujar.
I'm here.
Camel. Camel is here. Wait, let me check how many scans here. 29. Okay, Camel is not here. Camel, I didn't see her lab report. Shaver.
Here.
Nice.
Anais, yeah, I'm here.
Nice. Thanks for. Mohammed. Musa, Mohammed.
Oh, yeah, I'm here.
Yeah, I'm here. Oh wait. Okay, never mind. It's a different person.
Sabiha.
Here.
Mia.
Here.
Mazar.
Yeah, I'm here.
Matthew.
Here.
Josh.
Here.
Jimenez.
Jimenez here.
Jimenez, sorry. Jimenez. Honig. Honig. Honig Ali. Hins.
Here.
Oh, okay, wait. The first name. Oh, sorry. I'm so confused. I saw the first column is the first name. Mo.
Here.
Ziyang.
Here.
Mark.
Here.
Peter.
Here.
Michael. Arthur. Fadia.
Here.
Alexander.
Here.
Yasin. Sorry, you corrected me earlier. Yasin. Is Yasin here? Yasin, he's here. Passing Anika. Oh, maybe she dropped. Ali.
Here.
Okay. So in the end, I will update the grade here by the end of the semester. So this is your this is the form I will submit to physics department. They will upload.
I think there's a person left. The first person.
First person is left. Anika. Oh, I forgot. I saw this.
I'm here.
Okay. No, why which one is great? It finished. Okay. So please, if you have any questions, please upload your question to the Excel sheet. And then we will meet next Tuesday. So, yeah.
We meet every Tuesday now.
This lab report due next Tuesday. And last semester we don't have like we don't meet every week. We meet every 2 weeks. So I kind of want to know what you guys think. What you guys think?
Yeah, can we just do what we were doing, meet every other week?
How about later? I would just like make a poll, like everybody can vote. Of course, I'll be available when you have a question, but we just don't have to like mandatory to make meet every Tuesday. So I think I guess give you less stress because this lab is not very difficult, and I also want you guys to focus more on your like difficult courses. So if like later I would just drop if you want to have a question you want to discuss with me, like just send me like a email, say okay we discuss the time, then we can meet separately, and we don't need to meet every 2 weeks every week. That's my thinking, but you also have a right to like sit in class on time. Yeah, I just like make a poll like after this class so we can discuss later. Because if you have any question from homework or from your textbook, you can just feel free to ask me. Last semester there was student, because last semester we only meet every 2 weeks. So there will be like so I think the student also feel like a lot less stress because even it's not difficult, but you have to come here because I take attendance. So it's give you, I'm also like a student, so I feel like oh, it gave me some pressure. But if you have questions, just feel free to ask me. And there was a student, he he scheduled like an individual meeting with me for his homework discussion, and it went pretty well. Yeah, I think I didn't say there's necessarily meet every Tuesday. Yeah, I just like collect everyone's opinion. So how we conduct so the recitation part. Okay. Yeah. Okay. Thank you all. Thank you for so much.
Thank you. Have a great day.
Thank you.
Thank you, Professor.
Thank you, everyone.